Good morning, good afternoon, or good evening, depending on where you're joining us from today. Welcome to today's webinar, Unifying Your Flood Modelling, sponsored by Jacobs. And this is the first of 3 webinars that Jacobs are hosting. But if you want to join the 2 and 3, you'll have to wait till after Christmas because they will be in February and June next year. I am your chair, Sophia Buchanan. And I've got the easy job of just introducing the speakers and the webinar this morning, but I am joining Jacobs' team officially next week as the representative for the flood products for Australia and New Zealand. I'm always surprised when I join these webinars of what the reach is from the Australian Water School, how many people across how many different countries are joining us today. And today's webinar is no different. We have over 500 registrations, and you can see how many people are joining from all parts of the world. So thank you for those that are joining at midnight in the UK. All right, so today, as I said, I've got the easy job of being the chair. We've got 2 great experts with us joining from Jacobs. We've got Adam Parks, who is the Technical Director for the Flood Products, and Phil Paduco, who is the Global Solutions Director and also a Principal Hydrologist from Jacobs. And I know you both have an extensive history in the water engineering space. So Adam, do you want to tell us a little bit about yourself?
Thank you, Sophia. Good morning, good afternoon. So I'm dialing in from the UK, where it is just gone midnight. So hopefully I'm coming across suitably enthusiastic. I've been in the industry now for a little over 20 years, and the vast majority of that time has been delivering flood risk modelling, hydrology projects across the world. Modelling, hydrology, flood mitigation schemes, flood forecasting. And most of my career has been at Jacobs. About a year ago now, I moved into our digital flood products unit to support development of some of our great products, including Flood Platform, which we're talking about today. I'm really keen to show you what it can do and give a good live demo over the next 40 minutes or so.
Thanks, Adam. Phil, do you want to tell us a bit about yourself?
Yeah, I'm Phil Paduco. I have the luxury of being here in Melbourne, just looking out the window, which isn't the most glorious day, I admit, but nonetheless, it's not midnight for me. I'm the Regional Solutions Director for Australia and New Zealand for the Natural Resources business. And like Adam, I probably spent a good chunk of the last quarter of the century focusing on flood modelling and flooding issues, delivering a vast array of different flood-related projects and a couple of other hydrology-related projects and all sorts of things. I've worked across, Australia and Asia, New Zealand, UK, and here to provide some of the Australian context and what we're doing with some of our flood products, particularly Flood Platform.
Thanks, Phil. So as you can see, everyone, we're in very capable hands today. I'm just going to cover what they're going to be talking about, and then I'll pass it over to Phil. So firstly, Phil's going to talk about the industry problems and the challenges that we've been facing as modelers. I'm sure what he talks about will resonate with a lot of us, including myself. And then Adam's going to give an introduction to Flood Platform and also talk about how it can help through the different stages of the project lifecycle. And as he said, attempting a live demo at midnight, he likes to live on the edge there. And then, of course, we'll have time for questions at the end. But, of course, get in early if you want to. Put in your questions in the chat box, and Adam and Phil might answer them as we go. All right, my job here is done. Phil, over to you.
When I was asked to do that, Adam asked me to get involved with this. I reflected on the beginning of my career several decades ago, what it was like being a young modeler at that time and the pains I was facing. And, at the time I had to learn 2 different GIS packages, a ground modeling package, CAD, text editor, and all about DOS commands. I mean, I thought at that point in the world, DOS commands had died. But we had to learn all these sorts of things. And then the data arrived in CDs, and we had to pull that data off CDs. And for those younger people out there, you might have to Google what CDs are, but they were not a joy to work with. I can absolutely assure you of that. But that's the way the data arrived by post into the office. And fast forwarding a couple of decades, a lot of things have improved. There's no doubt about that. Some of our workflows, obviously, our models, our PCs, have all improved massively. But overall, I think most of you will agree who've been around for a year or two that a poor old flood model's pains have increased. They've increased because we've got more complicated models. We've got better data. We've got more things we want to do with our models, and we want to answer more and more questions. So overall, I think the pain has increased. And I'll just talk to some of those pains, and that sort of will set up, some of the things that we're trying to resolve and, address with Flood Platform. So getting data into our organisations. I know we've got online tools. We can share data really easily that way, but we're bringing in so much data. We're bringing in sort of LiDAR, mobile laser scanning, ground models, surveys, pit and pipe data, all sorts of things need to come into our organisation. We need to keep track of that and manage it. And Australia being a particularly large country, our data sets tend to be particularly large. I mean, we call a medium-sized catchment something like 1,000 square kilometres, which is a very large area, as I'm sure most of you appreciate. So bringing that massive volume of data into a safely and organisedly, is that a word? I'm not sure, into our organisations is still a challenge, and it really stresses and strains organisations' file sharing capabilities. And I still see hard drives arriving in the office on a fairly regular basis, and one of the drivers of that is not just the volume of data, it's also around security. So when we get to doing our work, we also have the same problem at the end, sending our data back to our clients and colleagues and other organisations. Because often, terabytes of data. We roll through 10 temporal patterns with however many configurations, different APs, mitigations, design options, etc. We generate so much data that this has to get back to an organisation. And I know that many of you on the call will be familiar with sending a hard drive back to a regulator, back to your design team. And those hard drives, well, the organisation's been around for a couple of years and they've built a couple of these hard drives. They tend to live in the fireproof in the basement, which of course tends to be, not flood-proof or flood-prone. So it's not a particularly robust way to share or store this valuable information. We have this legacy problem sitting there. So that's another one of the pains we're still seeing in our flood modelling world. And of course, during a project, we often want to share results so we can make better decisions with our design to inform communities and for our clients. And today, it still surprises me. People don't want to learn specialist GIS software. I don't understand. I mean, for me, it's a go-to, but many of my clients and colleagues just aren't that interested. So one of the challenges I think that came through in developing Flood Platform was, what if we use that in a familiar environment? What if we could share that data in a way that people could instantly use and understand and put it into the context of their actual problem? I could go on and on about all the pains that we suffer as poor old flood modelers, but I won't. What I'm going to do is hand over to Adam, who's going to tell you about some of the ways that Flood Platform is looking to actually address these challenges.
Thank you very much, Phil. A great introduction. I feel and share many of your pains around modelling. I think they're common, whether you're working in Australia, the US, the UK, or elsewhere. We've got so much work to do in our industry. There's only a finite number of resources, modelers available, and we do seem to spend a disproportionate amount of our time doing manual tasks and manual activities. And so there's a strong desire to be more efficient in the way we work. As Phil says, I'm going to attempt a live demonstration of some of our software and tools over the next half an hour or so. Before I jump into that, just to give you an overview of what the sort of digital tools Jacobs have are. So we've got Flood Modeler, Flood Platform, and Flood Forecaster. Today I'm talking to you about Flood Platform, which is a new service we're launching imminently. But we also have Flood Modeler. This is a tool that Jacobs have been developing and publishing for well over 30 years. It's a desktop modeling application. It's heavily used across the UK. And in fact, it links to TUFLOW, and the most dominant type of model you like to find in the UK is a linked Flood Modeler TUFLOW model. We'll continue to develop and publish Flood Modeler, and we're looking to launch version 8 next year. And the reason I mentioned that is we're going to introduce entirely new ways of building 2D models, both Flood Modeler 2D models and TUFLOW models within Flood Modeler, again, to bring some of that data management, that data sharing, and more efficient work to the 2D domain. and we'll talk a lot more about in the coming weeks and months. We've got Flood Platform, which is our cloud-based model management and simulation management tool, which I'll be talking about for the rest of this presentation. And just to drop in Flood Forecaster as well, this is a suite of tools which we've developed over several decades, which enables forecasting at both sort of hyper-local scale, so individual buildings, properties or assets, up to national scale and regional scale flood forecasting. And these are a toolbox of different systems and processes we have available to enable flood forecasting by private organizations, local government, national governments. But as I say, today we're focusing on Flood Platform. In respect of which tool, which product we're talking about, we've got an overarching philosophy we try to introduce when Jacobs are producing these tools. Ultimately, what we want is our tools to be easy to use, robust, and fast. No matter where you are in your career, from that early modeler, that young Phil managing CD-ROMs and other data sets, all the way through to now Phil, the expert modeler who wants access to all the data and all the software and all the packages. And so that intuitive design is really important to us. A big change the way we work is sort of making better use of user interface, user experience designers when we're designing and building our software to make it easy to learn. There's a hugely steep learning curve when you pick up modeling. Talking to colleagues recently about all the software that our graduates have to learn how to use. We want to make that easy. We want to make that enjoyable because we want people to have fulfilling careers within the industry, and also we want them to be able to work efficiently and feel like they're achieving things. We want it to be enjoyable to be a modeler. Perhaps a bit of an oxymoron, enjoyable modeling, but that's our target. That's what we're aiming for. So as to say, modeling is made up of lots of really complex tasks and processes, and any modeler will very happily tell you at length how hard modeling can be. So when we've been designing Flood Platform, we have been asking the industry what your biggest pains, challenges are, and what your vision is for the future of flood modeling. And we literally have gone out and asked users, practitioners, stakeholders, clients from across a range of backgrounds and geography. And the aim of this was to identify areas where we can really bring improvements to people's working lives and bring efficiencies to how they work. And through a series of interviews, surveys, workshops, we found the responses broadly fall into four main categories. And it doesn't really matter if we're asking people in Australia, the US, the UK, or elsewhere. These categories are all fairly consistent. These are where the pain points are. These are the areas of improvement can be. And we trust Flood Platform addresses many of these. So collaboration first, that piece Phil was mentioning about how do I share data? How do I manage and share this data? So it's absolutely essential we collaborate as modelers. We're not working in isolation. We're working as part of multidisciplinary teams within our organizations and part of wider partnerships and teams with our clients and our stakeholders. And one of the common issues, how do I share my model and model results with others? How can I send these across to clients or regulators so they can review them when these files are just huge now and email is just an absolute non-starter? And the other challenge is knowing the person receiving those results, can they open them? Can they view them? Do they have the ability to interact with those results? And if not, how will they do that? And a huge amount of time is spent on that collaboration piece. Sharing data links nicely into data management and version control. I know when we've been building models, when I build models, we're creating large amounts of files, layers, simulation, input data. We make further changes all the time and we make new versions all the time. We need to be confident we've got the right versions for when we're running different return periods, different storm profiles, different sensitivities. Particularly when we come to package these models up to send them on to someone else. Have I included superseded files? Have I provided the right data? And equally, have I got enough storage for all this? I'm sure many of the modelers on this call would have had those lovely Friday afternoon jobs of trying to clear enough space on the server for your runs to go over the weekend, or to have enough space that your IT department don't come tracking you down on a Monday morning because you filled the server up again. So managing that server space, managing that data is a critical part of what we do. Technology is a fairly broad term, but it covers a large number of areas. The tools we've got available to us, particularly the automation tools, have expanded massively over the last 5 to 10 years. And I think many of us can see how they could be used to make our lives, make our work easier. But the challenge is bringing to bear. We often have unstructured data. We have different ways of working from each organization between different modeling packages. So it's really hard to make use of these new tools. And those tools, such as automating tasks, making sure the models are built right the first time, so avoiding rework, optimizing our models, so calibrating and verifying our models, are all key tools which we want to bring to bear, make easier to use. And the other point here is we're running our models more frequently, larger numbers of iterations of our simulations. Do we have the software licensing? Do we have the compute resource enabled to do that? And the final point is security. And this is something we often don't spend enough time talking about. And I'll divide security into two parts. We've got the robustness of our data stores, and then we've got the access control enforcement part. So that the data robustness is really important. With creating huge amounts of data, are we confident it's robust? I mean, Phil mentioned that the hard drives in cupboards or in basements. I've experienced that so many times where clients have come back to us years down the line and they've been unable to access their data, and they hope that we've still got copies of it we can reprovide. And this is data that may have cost millions to create and manage. And are we confident it's secure for the long term? And adjacent to that, this is also sensitive data. This is flood risk data. This is risk data. Are we sure that only the right people have access to it? What if that hard drive goes missing in the post? Can we be confident only the right people are accessing this data and demonstrate that compliance? And these are all areas where Flood Platform will help. So what is Flood Platform? Flood Platform is a tool that Jacobs has been using internally now for the best part of 15 years. It started life as a efficiency tool to manage some very large-scale national mapping projects that Jacobs were undertaking. And it's then been refined and evolved over the years to the point where it is now the platform that Jacobs use at the moment internally to manage all their modeling work. So it's a unified modeling platform which allows us to run TUFLOW, Flood Modeler, HEC-RAS, SWMM, and other models in a consistent way to store our data consistently across our IT estate and to effectively manage all our modeling projects. And so it brings huge efficiencies to our internal users, as well as efficiencies for our non-modeling users as well, enabling them to access that data, to share and collaborate on their data sets. And now we're bringing this as an external product to the industry, looking to launch this in January next year as something pretty much anyone can use. Flood Platform is a cloud-based service, accessed via a web browser, and the intent is it digitize the model build management workflow, connecting processes with built-in collaboration tools. There are several key components to it. So we've got model management, that piece that we've been talking about a few times already today. How do I manage these huge data sets across multiple teams, across multiple geographies and regions? It's quite common. Some of our projects now call on resources from multiple continents, all having to work together efficiently. How do I manage all that data? Visualization, and I'm going to demonstrate this shortly. How do I see the results? I've got all these results files. How can I access them? It's a pain to pull those down to your local computer to use specific applications or desktop tools to visualize the results. I want to be able to see those within Flood Platform, and I'll show you all that shortly. Simulation and analysis. This is running your models, and this is where Flood Platform has been incredibly powerful for Jacobs. We're running hundreds and hundreds of models at any given time internally across our network, and the system coordinates all those simulations, identifying slots on execution nodes, allocating licenses, and allowing us to track the progress of simulations. I say when we launch Flood Platform externally, it will work with Flood Modeler, TUFLOW, HEC-RAS, and SWMM, and we're looking to add more solvers over the next 12 months as well. Collaboration is by far and away the most impressive part of what this can do. The ability to share your models internally and externally at a click of a button. No more moving data onto hard drives, no more hoping there's enough space in the server. And I'll show you how all that's going to work within Flood Platform. As well as the modeling, we want to expand the digital workflow beyond just the model build and run. We want to get to the point where you can also create your deliverables straight out of Flood Platform. All that data is in a very structured form within Flood Platform, enabling us to create reports, create model logs, simulation logs, quality assurance reports in an automated way. Again, saving you time and effort so you can spend more time on the quality of your modeling work. And of course, I mentioned security and compliance, giving you confidence that only the right people have access to your data at the right time. Before I get into the live demo, just to give you an overview, so Flood Platform is a cloud-based service running out of Azure, and it's accessed via a web browser. So whether you're a model creator, a stakeholder, a client, you all access the system via the same secure gateway with two-factor authentication baked in. Once you're into Flood Platform, depending on your level of access, you have the ability to use the tools available within there, and that includes things like model upload and version control, a spatial catalog to see where your models are. Have I worked here before? What data are available here? Your model simulation tools, calibration and verification tools, quality assurance, which I'll show you in detail later on, as well as the report builder, model sharing tools, and comment and review tools. And at the end of a project, the ability to archive data in a secure way, which is you can get back and also manage that data efficiently. And all this is underpinned by our cloud data storage, so effectively unlimited amounts of storage available to you, our automation of standardized tools, of standardized processes, those modeling applications I mentioned, Flood Modeler, TUFLOW, HEC, and SWMM to be expanded. And the real great thing about the cloud, that ability to have that elastic compute capability, both CPU and GPU, you can scale that to your needs. So no more waiting for the right PC to become available. You can just run those simulations as you need them. And increasingly, we're using machine learning and AI to bring further efficiencies. That will include things like automatic calibration of your models and verification of your models using these machine learning tools. Okay, so a live demonstration, dangerous at any time, let alone midnight. So I'm going to talk you through how Flood Platform can be used through a series of questions around a sort of standard workflow. So first off, how can Flood Platform help me throughout my modeling life cycle? So this is what, to me, is a typical life cycle of a model. So we're starting off with an existing model. So a client or a regulatory body has given us an existing model of an area, and we want to use that to understand the flood risk, enhance that model, and undertake some work. It may be for development, it may be for mapping, it may be for a flood defense scheme. And we're starting with that initial problem of that big zip file of data you've been given on a hard drive for a download. You don't know what's in there. You need to understand that data and work with it. You need to update that model to include new data, new LiDAR, new boundary data, undertake your simulations, and that could be into the hundreds, if not thousands, of simulations. Once you've undertaken those simulations, you need to QA them. You need to give yourself confidence in the quality, as well as sharing them both internally with your user base, as well as your clients externally, so they can comment and feedback. And finally, you need to make your deliverables. You have to produce your reports, your logs, and get them and that data across to your client. I'll show you how Flood Platform will help with each of these things. So first question, I've inherited a model from an existing external client, and I want to review before I start doing my updates. And not unreasonably, you've looked at the folder and it's a bit untidy. So you've got this zip folder that's not following a good standard. Have I got all the right data there? What's in there? How can I be confident I've got what I need? So at this point, I'm going to jump into Flood Platform. I hope everyone can see my web browser. This is the beta of Flood Platform, which we're currently running, and I'm going to log on to the system. So I logged on shortly before then. I'm just being asked for my authentication. So I'm just grab my mobile phone and do that. Give me 2 seconds. So there's a two-factor authentication by default. And it's just checking that's me, which it is. So that should go green and let me into the system. There we go. And I jump to the dashboard. So when you first land on Flood Platform, and I just stress this is the beta, so it's going to be refined more before we launch in a few months' time. We can see all our model files, and our data is organized by model, project, and workspace. So the intention is that your projects contain multiple models, and I'll show you that in a second, and your workspaces contain multiple projects. And it's really flexible. It's up to you how you arrange this data. So a workspace may be per client, so you may have all the modeling work you're doing for one client, all the modeling you're doing for a particular office or region, or it could be with all the modeling work you're doing in a given country, or it could even just be for one person. It's really up to you how you structure that data. In this example, I've got some data from an existing model, an existing client. I want to see what's in it. So I'm going to create a new workspace. I'm going to give this a name. I can give it a project code. There's only one organization at the moment, which is Jacobs, but you can work across multiple organizations. And what else we can do is we can put geofences in place. So a geofence allows us to start sorting that data and specifying where it is. It helps us spatially understand what that data is, but also put controls on what's happening. So in this case, I'm going to say that workspace is pretty much all of Australia. I create that workspace. It pops up here. I'll open that workspace and I'll create a new project. So again, this is and I can refine my my area. And the important part about this, it prevents people from using a workspace where they shouldn't. So this is an Australian workspace. I don't want someone from the US team using my storage or my compute allocation. So I've got my my project now, and I can have as many projects in here as I like. I open that up, and I'm going to add some modeling data. We're using the term model category because we recognize each project may have multiple models in there, so covering coastal, fluvial, groundwater type models. In this case, it's a fluvial model, so I'm going to give it a name. Lost the ability to type, it would seem. And this is a TUFLOW classic model. Create that. And now I want to upload that model. So click the upload button. I'm going to go and grab my folder full of data. I'm just going to upload a really simple model for now. And click upload. So if I'd open that file, that zip file up on my desktop, what you've seen is a reasonably complex TUFLOW model. And what Flood Platform is doing now, it's uploaded that data, is it's scanning that file for all the component parts. So it's identifying all the TCF files, all the batch files, and tracking those down and passing out all the individual simulations for me. This can take a couple of minutes because it's tracking down every single link across there. I'll leave it going, but what I'm going to do is jump back to my dashboard and open up that same file which I uploaded earlier. So I did that just before this call started. It's exactly the same data, and you can see this one's showing as ready. So a couple of hours ago, this was processed. And I can jump into this. And so click on simulation. And you can see what it's done is it's worked out all the simulations that were provided in that folder, all the way from create empties. Someone's created that model file and various bits of version control. None of these models have been run. I will jump in some that have been run shortly. I've got all the composition files, so all the files that make up that model are available to me. So I can see all the TCF files, all the model files are available in here. So I can say, I can look at a TCF file, and I can see how that model is structured. I can see the TVC files, there's a TUFLOW model, the TGCs, other data. So I can see all the files that make this up. And before we launch, what we're working on at the moment is refining this view. So we've got all the thematic mapping of the colors in here, and also the ability to view spatial data in here. And the really nice thing it does as well are checks. So what these checks are doing are looking for missing data. So at the moment, it's got two configuration issues. If I click on these, the error message could be a bit clearer, but ultimately what it's trying to say is that my LiDAR is missing. So there's the upload file I provided was missing the ground data, the LiDAR data as a geotip, and therefore this model is just not going to run. So it's scanned through all those simulations, identified that these 2 bits of LiDAR are missing, and it gives me the ability to upload those missing files. So what could have taken hours to search all those models and find missing data has been done in a few seconds, and it gives me the ability to upload the missing data. The other important thing when you're looking at these is, okay, so what have I actually got in here? So I'm going to go back to the example data, and I'm going to open up this classic one here. Go back in simulations. So again, these are files I uploaded earlier, and these have been run. So you can see these 3 simulations have all been run, and they're currently processing. I've left this one processing so you can see what's happening. So when you upload a model to Flood Platform, not only does it work out what simulations you've got, it also processes the results in a way that you can visualize them in the web browser. It's doing some clever things behind the scenes to break up those big results files so they can be seen. So if I open up this 1 in 75-year run here, I've got some details about it here, which you've got control over those. If I click on results and give that a second, the software's passed out all the data in the log files, so I can quickly see some key information about that simulation, how long it took, errors, number of warnings, and so on. And I can also see these nice plots showing me how the simulation progressed. So I can see the cumulative mass balance error and the number of wet cells and so on. And this is customizable. You can see different plots depending on the solver and what you're interested in. I can also see the log files as well. These often take a few seconds to load, but this will pass out the TLF file in this case, so I can inspect that and understand what's going on within the simulation. The really nice thing though is I can look at some results. So if I click on this button here and pop open a new window, this is somewhere near Canberra. This is a very simple model. And the first thing I look at is, say, the maximum flood extent. So I click on that button there, and I can see I've got these 2 rivers here with a 2D flow being inserted, and that's flowing down through this town here, creating a flood envelope. And if I zoom in a bit more, I could perhaps put on the maximum vector data as well, so I can see the velocity arrows. That'll take a second to load. There we go. And I can zoom straight back in. I can see my results from my model live in here. And I can add on additional results from different simulations as well. But as well as seeing the maximum, the really important thing is to see the propagation of the flooding. So I'm going to add in the temporal depth data, so time-varying depth data, and click go. And so what this is doing, you can see the water starting to appear here. It's plotting out those that flow data. So we've got water coming down these 2 tributaries here and starting to plot out. And again, I can, as that's playing, I can zoom in, I can pan around. I'll be able to change the background mapping and other things as I go. I can also add in the velocity vector data as well, so I can really understand what's going on with my model. And this was all data I uploaded a bit earlier today. I can skip backwards and forwards through this and examine that data. And I can also bring in the velocity data as well. And one thing will be available in the beta shortly is all the check files too, so you can see the Z point checks, the grid checks, and so on. We're just finishing the style on those. So this on its own is a really powerful tool to enable me to understand my models better, to understand what's in those zip files really, really quickly. Jumping back to the presentation, just some screen grabs. So I've got my data. I've had a look at it. I see I've got some models that haven't been run. So going back, those files I uploaded earlier hadn't been run. How can I do that? So again, jumping back to Flood Platform and going back in. Let's go all the way back up to that model I uploaded a second ago. That should have processed by now. Yep, there we go. So that model I uploaded earlier is ready. So it's been processed. And I can see I've got all these simulations in here and none of these have been run. So I can jump into any of these I like and I can click the Send to Queue button. That will initiate a run. So if I click on that button there and click Confirm, that will spin up in the background. It'll take a few minutes to spin up because we haven't got many models running at the moment. And what that does is it spins up a virtual resource in the cloud, and that will start running the model. And the resource will be dependent on the type of model. If it's a HPC GPU run, it'll spin up the right file. If it's a 1D HEC-RAS model will spin up a different sort of computer. And those will run in the background, and it will constantly provide you with feedback. That'll take a few seconds to load up, so I'll just show you what that'll look like. So as that starts to run, you'll get this plotting data coming back into the system. So you'll this updates every few seconds, so you can see the health of your model as it's running through. And you can run multiple models at the same time. So we frequently run hundreds of models in parallel in our systems using GPU and CPU compute, giving us the ability to run basically as many models as we need to match client needs. If I've made some updates to my model, how do I then run them in Flood Platform? It's really easy. You can, at the moment, you re-upload that model, so you upload those new components to Flood Platform, and you can set them off again. So Flood Platform allows you to run those models, but also lets you see how they're progressing. So we know when you're running multiple models, lots and lots of different models, you want to be able to have confidence they're running well. So we'll create these dashboards which allow you to monitor the progress of each individual simulation or each group of simulations, so you know which ones are running well, which ones perhaps need some attention, and which ones need some support as well. We can also issue alerts as well, so though that horrible feeling when you press go on a model and you go away, you don't need to constantly keep looking at it. You'll get alerts to the system telling you if there's a problem or when your models have successfully run. A key challenge we face at Jacobs is how on earth do I QA all that? I've run that model 1,000 times. I want to QA. I want to have confidence in my models. How can Flood Platform help me? This is something I can't demonstrate yet because it's still being finalized, but it will be in place when we release the software later in the year. What we're looking at for every single simulation is we'll run what we're calling pre-flight, simulation, and post-flight checks. So as the models, before the model runs, it will be checked for common errors and mistakes. That could be things like very unusual Manning's values, missing data, mismatches in input data between simulations. And what you can do on each simulation is see the status of those pre-flight checks. So they've been completed, have they been passed? The ones that haven't passed, what's the problem? We can have run status, so this is monitoring the logs during the simulation and providing you feedback on that. What's the mass balance? Have you got any negative deaths? Has the model become unstable and fallen over? And then we've also got post-flight checks. And this is a wide range of tools to check your model results, not just the health of the model, but also compared to other simulations. So, for instance, I've run my model for a range of different return periods. Is my 100-year flood outline bigger than my 75-year and smaller than my 200-year? Have I got any glass walling? How do my results compare to observed flood risk in that area? We're automating all these tools to give you confidence in the results and the ability to dig into these things. So rather than taking hours and hours to check the simulations, it can be done in a few minutes. As I say, we'll also introduce a range of dashboards which allow you to visually inspect these results as you go and compare different results from different simulations. The next one, and this is a really powerful part of Flood Platform, is the ability to share the results. So it could be that your reviewer is in a different office and doesn't have direct access to your data. It could be your reviewer works for a different organization. How can they access that data in Flood Platform? So we're going back into Flood Platform and choose this example here, this workspace. You've got full control over who can see your data. So under the Permissions tab, this is where you can start to add new users. So maybe I decide to add my colleague Luke into this project. Just click Add User. Let the page refresh. I can now see Luke's in there as a viewer. So I can choose the sort of role Luke has got, whether he's a member, an admin, an owner, or a viewer. And I can add as many people in here as I like. They can be both inside my organization and external users as well. And we've got very granular permission management as well. So I can choose what a viewer can do. Can they run models? Can they see results? Can they share things? Can they download things? You've got very granular control over who can do what, which gives you confidence that you're sharing the right data at the right time. You can time limit these things as well. And it's so easy to add new members into this to let them share. The other thing we're doing around collaboration, besides the sharing permissions, let's find the right slide. Here we go. That model view I showed you earlier, we're having a reviewer version of that, so you can add spatial commentary on here. So it's really hard to review models and get feedback. There's nothing worse than getting an email with hundreds of bullet points in it. What we want to make that is a nice collaborative process. So when you look at these flood outlines, maybe you can add spatial comments. You can say, oh, I don't believe the flooding here, or this isn't correct. Your reviewer or your client can provide those comments, and you can respond back in a back and forth way. So you get these threaded comments and feedback, and this stuff can be persistent as well. So if comments aren't closed out, this data can remain persistent within the system, so you can see it when you pick that model up again in 6 months, 5 months, 5 years. What were the issues when that model was originally signed off? So it's important to get all that background context as well. So just before I wrap up, what else can we automate? And that's the heart of what we've been doing with this. What else can we do? What can make our users' lives easier? And this is really why Flood Platform has been so popular within Jacobs over the last 15 years. So reporting is absolutely essential. So we've got all that data in a nice structured way. We're labeling our model runs. So as you upload your models, you're specifying return periods, scenario types, climate change epochs. This enables us to automate report building. So you can create model logs, you can report simulation logs, quality assurance logs, create figures and diagrams all within Flood Platform. So you get these standardized outputs that can be produced by Flood Platform, then shared with your users. This is something we're working on hard at the moment. We've got a lot of tools available already, and we're migrating those into this web environment so you can have access to those within here. And this is something you can easily add on to. These are things we can enhance as we go. Key ones we produced for UK modelers are things like structure logs, which enable users to sort of populate data about in-river structures and other things, and then produce those as standardized outputs for our clients. And these can be really powerful. Before we jump into questions, I suppose, when's this going to be available? You see it's advanced. The version we use internally has been in place for 10, 15 years. The external version is currently in beta trialing. So we're trialing internally with Jacobs for our users, and we're also looking to trial with external users in the next couple of weeks. If you're interested in the trial, please hit our website, floodplatform.com, and there's a register your interest button. We're always on the lookout for external beta testers who want to try the system and try and break it for us. And then we're looking to launch this in January next year as Flood Platform, with all that functionality I've talked about available at the start. I think, Sophia, it's over to you for Q&A.
Thanks, Adam. Exciting stuff. I'm so excited that I joined the Jacobs team to be part of this. But guys, if you're as excited as I am, don't go join the team, but go and sign up to be a beta tester and give this thing a go yourselves. You can scan the QR code on the screen there to get started. So I'll start with just reading out some questions and throw them over to Adam and Phil. The top voted question there, which is the one that software developers always hate to answer, but I'll ask it anyway. What's the subscription fee for Flood Platform?
Yeah, not unsurprising that question has come up. Thank you, Sophia. So the way we're going to manage subscription to Flood Platform, it will be a subscription service, so a per seat license. So similar to things like Office 365, you buy a license per user. So if you've got 5 named users, you'll have 5 people with access. There'll be different tiers of user, and that will largely be tied to the amount of storage available. So the intent is we'll give flexibility to organizations. Some organizations will want loads of storage and very little compute. Others are going to be more compute intensive. So that's going to be the main way that will work. We haven't set pricing yet for Flood Platform, and that's part of this beta testing period. So we know we've got a rough idea of where we're going to be, but the beta testing will let us understand better what the cost of the compute, the cost of the storage, the way users will work will be, and what we're really targets on doing is bringing that price right down. All the things we've been doing around here are recognizing that there's a cost involved with this. All these features will bring great benefit, but that needs to be reflected in the price. So some of the things we're doing to reduce the cost of the service are use of things like Linux-based solvers. So Flood Modeler, TUFLOW, HEC-RAS, SWMM all have Linux solvers available. And by using Linux in the cloud over Windows, it halves the cost of the compute because you're not paying for that Windows overhead. We're optimizing simulations. So when you're running simulations, we're optimizing them so you're only using that expensive compute for the period you actually need to through clever pre-processing and post-processing, and also very active management of data. So all that data stored, and Jacobs generates terabytes of modeling data every month. We're very careful about how we store that data in such a way that the stuff you need immediately is in hot storage, the stuff you need less regularly is in cold storage, and ultimately the stuff that's finished with is an archive. So that data is still secure, but it's in a very efficient way of managing the data. It's a bit of a dodge on the question. We will be a subscription seat model, and we'll be looking to release pricing very soon. And we do appreciate any feedback we can get, particularly for our beta testers, will really help inform that question.
Thanks, Adam. Okay, much simpler question for you. How can the platform handle feeding multiple scenarios, APs, and durations? As you probably know, Australia has on available. Lots of events to get through.
Absolutely. So we can handle these. So currently I've got projects where we're running several thousand simulations to do different permutations of climate change, storm duration, return period, and development scenario. So Flood Platform can deal with those very easily. We can upload and parse out data from TCF files. So if you've got a model that's running multiple TCFs, or you've got batch scripts or logical batch scripts being used to run those TUFLOW models, Flood Platform can deal with those. One of the data files uploaded earlier was based on a logical batch script. I think there was one TCF which results in about 400 simulations. Flood Platform can parse out those simulations from those batch scripts and run them individually. We'll also be introducing a simulation builder tool. Our user experience developer, Rob Donegan, has got some really exciting ideas about how that's going to look. So we're looking at a visual simulation builder tool. So if you have got all those different return periods, storm durations, input files, how do I convert those into the permutations I need? And we've developed a really interesting way of doing it. We don't want to demo that quite yet. It's really exciting. We hope to have it out now, but it will be in the release come January. That'll let you build those different scenarios, all those different permutations you need, run them all in Flood Platform, or on your own system once you've built the simulations, manage the data within Flood Platform, but also a lot of that analysis that needs to be done. You talked about all those temporal patterns, all the different storm durations. We're often having to merge those to create your final flood map. So we'll add those tools within Flood Platform.
Adam, it's probably worth mentioning, we already do that. Like on some of our live projects in ANZ, we're actually doing exactly that with Flood Platform. So it's part of the capability already.
Absolutely. As I say, the Flood Platform has been used internally heavily by Jacobs across the globe, and that's the reason we've got it to manage all those different simulations, all those different permutations.
It's always good to have someone else as the guinea pig. Okay, how flexible is the system for different types of models and their folder structures? Is it always doing flood modeling, or can we handle other things such as erosion modeling?
That's a really good question. So when we design the system, we're aware of how modelers are, certainly how I am. I don't think I've ever come across two model folders that are the same. Everyone structures their models differently and manage their data differently. Flood Platform is really capable of inputting that data. So all those models we've been uploading to it have come from either benchmarks or real world modeling scenarios, and every organization does things slightly differently, and Flood Platform is able to manage those data. It digs back through those data sets and it restructures the data in a sensible way. It definitely doesn't have to be just flood modeling. So the initial solvers we'll launch will be around the key flood modelers, Flood Modeler, TUFLOW, HEC, SWM, so SWM being urban modelling as well. We're also looking to add other solvers and other ways of working. So we've got colleagues who are using Flood Platform to do wave overtopping modelling, using CFD, for instance, internally, using OpenFoam. That's definitely something we want to look at adding, as well as other types of solver. Basically, if it can be licensed and run in a container, we can do it, and we've had some great success with it so far.
Yeah. As an example, we're investigating other, outside of flooding, outside of water, groundwater modelling is one of the areas we're investigating through ModFlow. There are a couple of other pieces of software we're also investigating.
Thanks, guys. Can you give us a bit of information on how powerful the instances are for simulation speed? We've got simulation saying TUFLOW GPU simulation with Quadtree, wanting to compare with the company's existing resources.
Yeah, absolutely. We're doing an awful lot of benchmarking at the moment. So there's a balance to be had between the speed at which you can run your model and the cost of running that model. So some of those really powerful virtual machines are quite expensive on an hourly or a minute basis. We're doing the compares now. We've got some comparable results. So we've got things like the TUFLOW benchmarking study, which is really useful, so we can compare against that. We will be publishing benchmarking data. I think the power of Flood Platform is not the time it takes to run one model, but the ability to run hundreds of models in parallel. So it may take you 6 hours to run that simulation. If it takes an extra hour, okay, that's not great. But if you can run 1,000 models at the same time in parallel, that is going to save you huge amounts of time and effort. So again, there's a balance between the compute capacity in the system, the speed, but we will be publishing all the benchmarking tests and giving the users some control over the type of compute they have access to.
Okay. Sorry, question just being reshuffled. Do you have to purchase your own TUFLOW license with this, or does the subscription cover it?
That's a great question. So Jacobs have been working with BMT since the early 2000s in partnership. So for instance, we're a reseller of TUFLOW licensing. We've been working with BMT to have a bring your own license model to this. So what we'd like to get to the point is where you can have your licenses for TUFLOW, your network licenses, which can be shared for your on-premise users and your cloud users. That will be part of Flood Platform. I think that's really important. You get the most use of the licenses you've invested in. If you do need more license, you can of course buy them, you can rent them, but the intention is the majority of users will be in that sort of bring your own license position where they can share their licenses across their internal compute, their own resources, as well as their cloud resources, and that'll be really simple through the cloud licensing options available through the Weeboo licensing and TUFLOW. Oh, sorry, just to mention as well, aside from TUFLOW, I know it's an Australian presentation, so TUFLOW is going to be the thing most people are interested in because Flood Modeler is part of the Jacobs family. Within Flood Platform, there'll be no licensing costs for using the Flood Modeler solvers as well.
Okay. I just realised Phil and Adam, I'm going through the list based on how many votes they've had. But if you see some questions that you want to answer, feel free to jump in. But other results stored in the Flood Platform's cloud, the clients need a Flood Platform account to access, or can it be exported? And I guess who owns the IP of the model?
Yeah, I just saw that. I was just going to say that's a good one to answer. Yes, so the results are stored in Flood Platform's cloud, which is Azure, is the back end to this. And so if you want to share that with someone, they will need a Flood Platform account. It depends what sort of access they need. So the intent is there will be a no-cost tier as well. So if you want to share that with a client or a stakeholder and they just want to look at the results, they will need to create an account. So we've got that security layer in place, so we know who's logging in and accessing that data. But there will be a no-cost tier of Flood Platform to allow you to share it with people externally who aren't going to be running simulations and so on, so they can view those results. And yeah, absolutely, the IP of the models remains with the users. This isn't the intention is this is a solver agnostic tool. We're not looking to grab the IP for these models. That resides entirely with the person who created it. it's up to you who you assign that ownership to. And for instance, what we intend to do with one of our bigger UK clients is to allow them, once we've developed models on their behalf, we can transfer ownership to them via flood platforms. Effectively, it moves from our flood platform area into their flood platform area, and they take ownership. So we're very alive to that situation, and we're aware that particularly some stakeholders, local authorities and so on, local councils aren't going to be able to sort of spend thousands on software licensing. This lets them look at their results, see that collaborate with you with no cost to them.
Adam, there was a question earlier, which I answered it in text, but it was just around that point you were making at the end there. Is this flood platform designed for people creating models, or is it designed for people using those results, like organisations like that have those rafts of models that they've built up over years in the millions of dollars or pounds that you're talking about?
Thanks, Phil. Yeah, I think there's going to be multiple personas, different use cases, and I think those are probably the main two. You've got the people who are trying to use this system to manage their model data, to run their simulations, and to build their models increasingly, and that will be really powerful for them. But equally, you're going to have that group of people who are model owners, so those clients, those councils, those regulatory bodies, those water companies who have got huge libraries of data they need to manage in an effective way, and this is a really efficient way of doing it. So I've got clients who have spent millions and millions of pounds developing models, and often that data is sat in hard to access areas. It could even be on hard drives in cupboards. There's a great risk there, and this allows that discoverability of the data. You can look at a map and see where your models are, and then you can provide them back to other people really quickly. So the intention is both those use cases were at the fore. The large model owners as well as the model creators are both key clients to us and key ultimate users of the system.
Struggling getting off mute. And just to follow on for that, there's another the use case there that you sort of demonstrated was that we can share these results publicly almost. Is that how are we addressing that question? Because that would be, for those model owners, that will be a fantastic thing to do, the collaboration and the consultation and the engagement.
Definitely. So we've got two types of share. We've got that sort of collaboration share, where you're sharing all the results and the ability to mark them up, and that interactive back and forth. That really is intended for internal users and approvers. We're also going to have a stakeholder share where you can create a map or a series of maps which you can share online with community groups, with other interested parties. And again, that enables that community engagement far more easily than previously. So absolutely, that's part of it, that ability to share with a wider group. That could be a community group, so they can comment and feedback. They'll likely get a more simplified view than the reviewers. They won't be able to sort of dig into the results at every single node, but they can certainly see flood outlines and maps and interact with that data really easily.
Thanks, guys. It does feel like we've almost thought of everything. There's still quite a lot of questions, but we're right on the hour, so we might hold there, and we'll have to get back to, Adam and Phil have to get back to everyone through an email through AWS. But summing up, thank you everyone for attending. The recording link will be emailed to you along with the certificate of attendance, and they're very generous. They're giving two business days, so you'll have that in your inbox. And just remember after the webinar to fill out your 1-minute survey just to help AWS shape the future of their following webinars. Thanks, everyone. Thanks, Adam and Phil, for your time, and thanks, AWS, for having us.